Right now, you're moving faster than a bullet. You cannot feel it, nothing shakes, nothing tilts. If you are standing anywhere near the equator, the ground under your feet is carrying you eastward at about 1,000 miles an hour, and it has done that every second of your life without once asking your permission. So what happens the day it stops? Not slows, stops forever. Before we go any further, do something for me. Close your eyes for 3 seconds and picture it. The sun stuck in one place, the sky refusing to move. Whatever you just saw in your head, hold on to it, because by the end of this, you are going to find out how close you were. And while you are here, tell me where you are watching from. Drop your country in the comments. It matters more than you think, because the spot you are standing on right now determines almost everything about whether you would survive what comes next. Ready? Start with the ugly version. The Earth halts in an instant, but you do not. Neither does the air, or the ocean, or your house, or the person sitting next to you. Everything not welded to bedrock keeps traveling east at the speed it already had, and the atmosphere arrives as a wall of wind that scours the surface down to bare rock. That version of the story lasts about 4 minutes. It is not very interesting, is it? So let us ask the better question. What if the Earth slowed gently over centuries and then simply came to rest? Now you get a world. The first thing to change is the shape of the planet. You were taught that the Earth is a sphere. It is not quite. It bulges at the middle by roughly 13 miles because spin throws mass outward, and that bulge is the only reason the oceans sit where they sit. Remove the spin and the bulge relaxes. The water has to go somewhere. In 2011, a geographer named Witold Fraczek modeled exactly where it would go. His maps show the oceans draining away from the equator and pooling toward the poles. 2 enormous polar seas, north and south, and between them, one unbroken belt of dry land wrapping the entire planet. Sit with that for a second. There is no Atlantic, there is no Pacific. You could walk from Brazil to Angola without getting your boots wet, and Canada is seafloor. Half the countries on Earth would be underwater, and the other half would be landlocked forever. So which half is yours? You would also weigh more. Not much, about 0.5% at the equator. That spin has been quietly holding you up your entire life, flinging you outward just enough to shave a little off the scale, and the moment it stops, the planet takes that back. And the sky changes. A day is one rotation. Stop the rotation and the only motion left is the orbit, so one full cycle of light and dark becomes one full year. 6 months of continuous daylight. 6 months of unbroken night. The sunlit half bakes for half a year while the dark half falls into a cold deep enough to freeze water out of the air and pile it on the ground. And every living thing on the surface has a problem, because almost every organism you have ever met runs on a 24-hour internal clock. Jeffrey Hall, Michael Rosbash, and Michael Young won the Nobel Prize in 2017 for finding the genes that keep that clock running, right down to the protein that builds up overnight and breaks down by morning. Your body would still keep perfect time. The sky just would not agree with it anymore. Now here is the part almost nobody thinks about. The wind would break. Every storm you have ever watched spin on a weather map spins because the planet is turning underneath it. That effect was worked out in 1835 by a French engineer, Gaspard Gustave de Coriolis, and it is the reason hurricanes turn counterclockwise north of the equator and clockwise south of it. Take away the rotation and the Coriolis effect vanishes completely. No cyclones. No jet stream, no trade winds. Instead, air would run in a straight line from the scorching day side to the frozen night side. One vast permanent current blowing the same direction for 6 months, then reversing. You would never need a weather forecast again. Would you actually want that? The oceans lose their engine too. No gyres. No Gulf Stream carrying warmth north. The great conveyor that redistributes heat around this planet is driven partly by that same deflection, and without it, the temperature difference between the lit side and the dark side stops being softened by anything at all. But the deepest consequence is not on the surface. It is 2,000 miles beneath your chair. Earth has a core of liquid iron, and that iron is convecting, rising, cooling, sinking. But convection on its own does not make a magnetic field. It has to be organized. In 1995, Gary Glatzmeyer and Paul Roberts ran the first computer simulation of the geodynamo that actually held together, and what it showed was that rotation is the organizing force. The Coriolis effect twists that churning iron into tall aligned columns, and those columns are what generate the field. Take away the spin and you take away the columns. The magnetic field weakens, not overnight but steadily and then almost entirely. And that field is the only thing standing between your atmosphere and the solar wind. We know exactly how this story ends because we have watched a planet lose. NASA's MAVEN mission, led by Bruce Jakosky, has been measuring Mars being stripped right now. Charged particles from the sun peeling gas off the top of the Martian atmosphere and throwing it into space gram by gram for billions of years. Mars once had rivers. Mars once had a sky. It lost its magnetic field first, it lost its air second. That is what a motionless Earth eventually becomes. Not frozen, not burned. Just thinner and quiet. So how likely is any of this? Here is the strange part, it is already happening. The moon pulls on the ocean. The ocean drags across the seafloor. That friction is stealing Earth's rotation a fraction at a time, and the day is lengthening by roughly 1 7/10 milliseconds every century. That sounds like nothing. Run it backwards and it is enormous. In 1963, a Cornell paleontologist named John Wells realized that corals are clocks. A coral lays down a fine ridge every single day and a thicker band every year, so you can literally count the days inside a year that ended 380 million years ago. He counted about 400. Not 365, 400. Which means the day back then was under 22 hours long. The dinosaurs lived on a faster planet than you do. The creatures before them lived on a faster one still. Every generation of life on this planet has been handed a slightly longer day than its parents got. And the moon, taking that stolen momentum, drifts about 1.5 inches further away each year. We know that number to the millimeter because Apollo astronauts left mirrors on the lunar surface and we have been bouncing lasers off them since 1969. The spin also stutters in real time. Richard Gross at NASA's Jet Propulsion Laboratory calculated that the 2011 earthquake off Japan shifted enough of Earth's mass toward the center to shorten the day by about 1.8 microseconds. And in recent years, geodesists including Leonid Zotov have been tracking something nobody fully expected. The Earth has been spinning slightly faster, breaking records for the shortest day ever measured. The planet under you is not a metronome, it has a pulse. So does it ever reach zero? No. The breaking is real, but it is hopelessly slow. The Earth and Moon would need something on the order of 50 billion years to settle into a locked, motionless embrace, and the Sun will swell into a red giant and swallow this part of the solar system in about 5. This planet will die spinning. That is the deal, that was always the deal. Which reframes everything you just heard. The oceans sitting quietly in their basins, the storms that turn, the invisible magnetic shell holding your air against the sky, the plain, boring fact that the sun goes down and comes back before you have finished being tired. None of that is scenery, all of it is one single property. Angular momentum, inherited from a collapsing cloud of dust 4.5 billion years ago and never once given back. You did not earn it, you cannot lose it, you are simply standing on it. Right now, you are moving faster than a bullet, and every last thing you love is only possible because you never stop.